I started to share my screen.
Yes, I can see it.
You can see it? Okay.
By the way, did you get the Zoom link for the staff meeting?
Yes, I can forward to you.
Yes, please send to me.
Okay, I will do it right now.
So, Victor, are you getting in the Christmas spirit?
Yes, I'm a little bit overwhelmed with tasks from the satellite, but I'm trying to reserve some time in the 25th for
If you want to
commemorating.
get in the Christmas mood, you have to have some Christmas decorations.
Ah, okay. I'll keep that in mind.
For example, you should get one of these.
Whoa. That is cool.
This will put you in the Christmas mood.
Yeah, definitely.
And probably laughed at quite a bit.
Yes.
Especially if you try riding a commuter train.
Whoa. That was a little bit embarrassing, but
I think in Japan, some people might call the police as a mental case.
A mental disorder, maybe. Yes. I can understand.
But in the university, we're safe because we have so many mental cases.
Right.
So let's get warmed up here. Can you say a few words about why you were inspired to pick this topic?
Okay. So let me share a little bit my image. Okay. My inspiration was like this. I frequently receive questions from students when they are starting their projects with Raspberry Pi or other single board computers. And they always ask me this question, like, what language should I use? So this is actually a question that comes from the students, and I wanted to do a little bit of research about this to give them some informed answers. So
by the way, did you ever ask this question to somebody when you were young?
I think I never asked it to a person, but definitely I asked it to the internet. I did a lot of search when I was starting. So yes.
So this is a fairly common problem for students.
I think so, because there is too much freedom in this case. You can use many languages, so people get confused that should I use this one, should I use that one, and it's hard to tell an answer because it relates to the problem they have, right?
Yeah, and in the old days when projects were several years long, you could make a mistake and backtrack and try a different language. But nowadays, schedules are so short, you don't have that luxury anymore. Is that right?
Yeah, exactly. And sometimes the what people call time to market is more important than to have the very well designed solution. So sometimes you're taking shortcuts, and at that point, choosing the right language may give you the advantage you need to finish on time.
Okay, that's a good introduction. It's 10 after 12 now. So I'd like to tell all the students if they have a question, type it in the chat, and then probably I will see it, and then I will tell our speaker that he has a question. So type your questions in the chat. And without further ado, Victor, you have the floor.
Okay, thank you, Mada Sensei. So, hello everybody. I'm Victor. And today I'm going to present about this topic, how to choose a programming language for your space project using a single board computer. So you can see my mail address in the bottom of the slide. So if you have questions after and you want to contact me, please send me email. Um, so first, quick introduction. What is a single board computer? So a single board computer, as the name says, is a complete computer built into a single board with all you need in a computer: microprocessor, memory, input and outputs, and other features for having a functional computer. So it's a computer in a board. And they are very interesting, and they have applications in space mainly because they are very small. In the case of the original Raspberry Pi, the size is similar to a credit card, and now there are other versions that are even smaller. And they have a very powerful processor, usually ARM architecture. And in practical sense, you can consider them to be around 10 times slower than the processor you have in your laptop. So you can do many things you can do in your laptop with these single board computers.
Victor, quick question.
Yes.
Two questions. So what's the definition today of Raspberry Pi? And the second question is, why did this become immensely popular?
So Raspberry Pi is actually they started this project thinking about restoring what computing was around, let's say, 70s and 80s, where people would buy a computer and try to program it and tinker with it. So it got extremely popular because it is cheap, and at the same point it was the first one. They started this, so it had the time to grow, and a community started. So when people go to choose a single board computer nowadays, they tend to choose what is very popular and has a lot of documentation, right? So they go for the Raspberry Pi.
But this is not produced by one manufacturer, right? It's made by many people, right?
It's actually made by, I think, two mainly manufacturers. I think it's made in the UK by RSC Electronics, and there is another one I forgot.
And are they compatible?
Yes, they are identical actually. But there is a foundation that created the Raspberry Pi specification, and then they sent to different factories to manufacture it and sell. So there is like a single, let's say, not company, but foundation or organization behind it.
And these Raspberry Pis are particularly suitable for small sats. Is that right?
Yeah, I think the pressure comes in reverse. The payloads, I think, let's advance one slide. Or better. Yes, this one. So mainly about this point number two. Sometimes your payload require these new interfaces, and you need something small to put inside a small sat. So people are going and start choosing single board computers as a solution, right? So continue a little bit. I think this is the point of why you choose. I don't think people choose it because it is better or worse. They choose it because they need it. So there comes a requirement. I need to use a special hardware, some camera, or let's say some SDR. It requires one of these high-speed interfaces, like USB, Ethernet, or MIPI CSI2. And then you decide, oh, I need something more powerful. So they end up going for these single board computer solutions. And the main difference between so it has the let's say more traditional interfaces: GPIO, I2C, SPI, and UART. But people choose it mainly for these new interfaces. And as if you go with this solution, then you have a full operating system, usually Linux. And as a consequence, these operating systems support multiple programming languages. And then we come to the point of the original question, like then which language we choose, right?
Quick question. So Raspberry Pi is by far the most popular, but are there some competing rivals?
Yes, there are. For example, this one on the left is from Texas Instruments, the Beagle Bone Black. It was a few years ago. They also launched, I think, a little bit later than the original Raspberry Pi. They entered the market. So these were, I think, the main ones in the beginning. We are talking now about maybe 6 to 8 years ago when this was starting to get popular. But nowadays there are several. There are multiple competing units, but the Raspberry Pi takes the lead just because it is extremely common. So you have a lot of information about it.
Victor, a quick question. On the third slide, you said it's 10 times slower than the normal PC. Is it an advantage or a disadvantage?
It might look like a disadvantage, but the PCs are extremely fast nowadays, so it's actually an advantage. It's really powerful. So this is an estimate that I saw in practice while measuring the performance of laptop and Raspberry Pi version 3. And I saw you can run things around 10 times lower than your computer, but the power consumption is a lot lower. So if you take into consideration the size, price, and the power consumption, you realize that this is actually a very good deal. It's 10 times lower.
Thank you.
So it's not the speed that's advantageous. You're saying it just requires far less current.
Yes, to do the computation. But at the same time, if you compare this one to the more traditional microcontrollers, the clock speed of this processor is in the order of 1 gigahertz or faster. So while the previous one were like hundreds of megahertz, so you can see like a very increase in speed compared to other technologies.
Okay, so cost performance is pretty good.
It's pretty good, and of course, power comparing to the microcontrollers is a lot more, but on the other hand, it gives you more interfaces for payloads. So that's the point. You have some time to use these new interfaces, and then you're required something more powerful. Okay, so going back to track. So we get to this point. How do we choose a programming language for this single board computer? And since like almost all of these single board computers are running Linux, then the problem is similar to choosing a programming language for Linux, right? So depending on how you classify a programming language, there are hundreds or thousands of programming languages, and that makes it a little bit difficult to choose. And like choosing the right tool for the jobs make the job easier. Choosing the right programming language for your problem will save you time and effort. And that's why I think it's important to think a little bit before choosing. And there is no single best programming language. I cannot give you a single name, but there likely is a best programming language for your problem, for your application. So that's what I'm gonna try to help you to find out. So
hold on, back one slide.
Yes.
A very early and famous programming language is C and C++.
Yes.
But you're saying in today's environment, C is not necessarily the best thing to use?
Yes. Usually in the microcontroller scenario, you don't have much options. They give you C and C++, but now we have multiple options. And there are cases when the best choice is not gonna be the traditional ones.
Ah, okay. So
yeah,
this gets to the meat of your presentation then.
exactly. So I think the most common way people choose, and it's not a bad way to choose, is to choose the language you know. So let's say you already know C programming language or C++ programming language. If you know you can solve your problem in the required time, then there is not much reason to go with it. So I would recommend in that case to go with the one you know. But if time schedule is short or you are not sure if it's the appropriate tool for the job, then it's worth like thinking a little bit more, right? So another important thing to consider is which language your colleagues are using in your work environment. For two reasons. One is that maybe there is programs you are inheriting from people that work in the past in your company or work environment, or maybe you want to be able to quickly ask for help for your neighbor. So these two things can help you a lot. And in this case, using a common language should be considered. But nowadays we have Google, we have internet to search for questions, so we can go beyond these 2 points, right? So I think the single most important strategy you should use in a single board computer is first looking for libraries and APIs. And to make this a little bit easier to understand is existing software. So if there is existing software you'll find in the internet that you need or want to use to make your life easier, then you should consider using a compatible language to that software, right? So I took three like real examples of what would be good choice for languages. So let's say I want to do image processing and I search the internet and I realize that this OpenCV library is a very good choice of software to help me solve my problem. Then I should look what this software supports. And the better supported language is C++. So in that case, I would consider C++ to be a good choice of language. So another real kind of real example. Let's say I want to use the Raspberry Pi official camera to take photos. And I found out that there is an official library called PyCamera that supports Python 3. Then the Python 3 would be a good choice of language in that case. Or let's say in the case that there is no pre-existing software, I made a completely new hardware and I need to access it through low-level APIs of the Linux kernel. I need to talk to it directly. So in that case, you look at the operating system language itself. The Linux APIs are written in C, and in that case, C would be a very good choice. So the point here is look at what exists already that can help you solve your problem. Look what language this supporting software is recommending you to use.
Victor, let's pause here. I think we have several members from Birds 5 project. Do you guys have any questions at this point? Birds 5 is moving along at a good pace, having started this summer. Birds 5 PDR is next week. So these issues that you have on this slide are relevant to Birds 5. So, well, I guess there's no question. Victor, please go on.
Okay. So I think my tip for Birds 5 would be check which hardware they're using, which library they need, and look at which language it was written in to as a tip for how to proceed, right? So then next move for a different like point, it it should be considered when choosing a language. So the popularity of the programming languages, it changes over time, right? So it's important to choose popular ones over unpopular, since there are more documentation, online forums, blogs, and good books written about it. And it is easier to get help. So you can find similar problems what you're facing and find solutions online, right? So
Victor, quick question. So
yes,
when you're programming, how often do you use Google to help you with your software problems? Is Google especially useful, or what is your take on that?
I think it's incredibly useful to search if you know what you need to search. So let's, if you know the right terms to search, you can get the information you need very fast compared to books, for example. But particularly when I'm going to learn a new language and I decide to learn it, I always take one book written about this language and quickly read through it so I can get the full picture in my head, because just searching for the problems on the internet gives you very small details, but it's hard to see the big picture.
Well, Victor, that's an important piece of advice. If you're going to learn a new language, you recommend buying one book on it and going through it
Yes,
at the initial stage.
I think is a good idea to have one for consulting, and mainly to get go quickly through it and try to get the big picture about the language, what this language supports, and then later you use Google as a reference to get particular details.
Yeah, okay, because I think a lot of people have completely tossed books out the window and just rely on
Fully on internet, right? But you can use the internet and look at the Amazon reviews, for example, especially in the United States version of Amazon, and
And
you can get.
when you read a book about programming language, do you buy soft copy or hard copy?
I prefer hard copy. The soft copy has one advantage that you can search quickly through it, but I think for concentration, I prefer the hard copy. But as I moved to Japan, I started to use soft copies and load in e-readers like Kindle, so I can not accumulate too much books at home. But I personally still would prefer having the real book. Yeah.
Okay.
So this graph you're seeing here is from this website called TIOB, and they do this TIOB index. So TIOB index, they actually they rank the languages according to the Google, not only Google, but let's say all the search engines, and they see what language has most of the results, right? So it is not a precise way to tell which is the most popular, but you can know which one is being talked about most in the internet as a whole. So I think things that are on top or going up in the SIOB index are interesting, and it shows the also market interest for the languages. So learning a language can also improve your curriculum for getting jobs. So it's good to get an idea what is like trending. And I also, from time to time, I like to take a look in the IEEE Spectrum magazine. They publish every year which are the top programming languages uh, that are like currently being used. And
Hold on. This
I
IEEE
recommend.
ranking is by what parameter?
Uh, it actually it takes very different kinds of information. For example, if you go to this website, you can filter like by job applications, for example, which language is training, or by simply popularity. They collect many times, and they also, since it's IEEE, they check the publications on the IEEE uh, magazines and journals, right? So they collect all this information from the articles, the internet, and at the same time they look for the jobs, what people are want to hire,
I
and
see. So if you want a job, you should master the top 5. Is that something fair to say?
I I think it's better to master one very well and look for, if you would be going simply as a programmer, purely programmer, would be better to master one than to try to do all of them. But yes, if you look at the top, it's where you should be putting your effort, not at the bottom, right? And if you're talking about SBCs and Raspberry Pi, then we are talking about embedded systems, and they also give the top programming languages for embedded. So this is what people are mostly using to solve their problems nowadays. So we should be looking at the top languages in this case.
Roughly speaking, why is Python so highly ranked?
Well, Python is very well ranked. I think I'm gonna explain this after about 2 slides. So
Oh,
I
okay,
ask
okay,
you to
okay,
hold on a little bit to
okay.
make more sense at that point. Uh, so let after looking at popularity and what other people are choosing in your job or what you already know, and I would we have to then look take like a deeper look. What is appropriate to use in the Linux environment and SBC environment? What makes sense to use, and analyze a little bit the strengths and weaknesses of each language, right? So as it's been talked about the most, I started with Python, and I think this will answer Maida Sensei's question. So Python is trending a lot. I think the most important point is it has excellent support for scientific data analysis, numeric algebra, and plotting tools. So in the scientific community and data analysis community, it has a lot of popularity. But it started to get this popularity simply because of this point number 2, that it does automatic memory management, and some, like, more technically they call garbage collection. And that means it does some work for you that you would have to do manually in languages like C, C++. It means less work for the programmer. The counterpoint is it will feel slower than other languages a little bit to execute, but it has a very good time to market. I think this slide is most focusing on why I would choose Python, but a point I didn't write in the slide is that Python syntax is very regular, and their philosophy is that there is only one way to solve a problem with Python language. So different people are forced to use the same approach to solve the problems, and it got extremely popular in the job market because it's easier to collaborate, because you're not going to get confused. You read the code from your coworker and it makes sense to you, and also because it's easier to replace the programmers inside the, the work environment, because if you change one programmer for another, they can quickly understand what other people worked before, and continue their work, right? So this very regular syntax makes it like very appropriate for the real world scenarios.
Victor, You say here faster time to market. Can you elaborate? I'm not exactly sure what this means.
Yes. So you can skip in a Python all this manual memory management. Uh, and also there is this excellent support for like excellent existing software for scientific data analysis and numeric algebra plotting tools, these libraries that help you to program. So by combining these two things, you can come up with a solution for the problem in a lot less time than, let's say, C or C++. Uh, so it will give you less time to market, especially like not just Python, but these high level languages. But Python, it has a lot of libraries. I think it's the one with like recently that I see that has most of the support for good libraries. So it will, if you use a library that already does most of the things you have to implement, and you don't have to worry about memory management, then these two things combined gives you a very like it shortens the time you need to come up with a solution.
It sounds like you like Python.
Actually, I personally don't like it very much, but I know when to use it. So I already did projects in Python many times. Uh, the reason I don't like it so much is because it forces you to think only in one way. And sometimes I like the creativity of thinking about different solutions to the same problem. But it's a more of a philosophical view. But I think Python is an excellent choice in most projects nowadays. And I choose it in the past and I was happy with the result. So I recommend, even though it's not my favorite. So if you continuing about the popularity, like we cannot.
Victor, can I make a comment?
Yes, please.
Yeah, Python is really probably it's also very easy to learn and very easy to begin with. But if you do a lot of computational fluid dynamics, or let's say if you analyze a lot of, let's say if you do finite element analysis where you need a lot of structured programming, I think it's very slow and it's really not good for such kind of applications. In that case, probably you might rather go back to Fortran or C++. I don't know what you think about that.
Yeah, I agree.
Yeah.
I think that's why I put this slower to execute. If you are used to programming C or Fortran and you run something in Python, you feel it's slow. It gets slow and this can accumulate. So yes, it has. Sometimes you have to do the more like to take the job and work more in the low level and do this memory management yourself, do all this algebra calculations on, let's say, skip the automatic matrix multiplication and stuff. It will give you more like, it will execute a lot faster. Right?
I agree.
So, yeah, sorry, I skipped a slide. So then the C is the other realm, and I think Fortran you can also take more or less the same idea that memory management is done manually. Your program will be faster, but it requires more time to program and debug. Debug, I mean, I emphasize, debug takes most of the time. So debugging these pointer problems or allocation problems can take a lot of time, but it will be faster.
Hold on, Victor. So you have more debugging to do, but if you're a sloppy programmer, then using Python doesn't help, right? You're still going to have a lot of bugs.
Yes.
What's the difference?
It's just that the bugs are easier to solve. They are in a higher level, let's say. If you're a sloppy programmer, you're gonna find bugs anyway. But I think if you take one problem and you implement one solution in Python and C side by side, I think you're gonna have a lot more bugs in C, especially if you're a sloppy programmer. So the numbers will increase because you do more things manually. So what Python does automatically, that thing is well done, right? So that part, you're gonna have to struggle with the bugs yourself.
So it's all that automation that slows down Python effectively, right?
Yeah, it runs on top of an interpreter. It's not compiled down to the hardware level, and it's hard to explain the technicalities about it. But in in this interpretation takes some time to do, so it makes it slower. But actually, that is also the magic. You would choose it because it's doing a lot of work for you. So
okay, so I'm starting to understand what you mean by
yeah,
faster time to market.
yeah,
It's taking a lot of laborious stuff out of the programmers.
out of the programmer's
Yeah.
responsibility. But it is not gonna be as good as it is if you do it well done in a low level language. It's not gonna be as fast, but it's gonna solve the problem. So sometimes solving the problem fast is more important than have the fastest program.
Yeah,
So
I
programmer
understand that.
time is important, right?
Some programmers just have a fetish for an elegant solution, right? So
Yes.
they end up spending excessive time on something they really don't need to do. Is that right?
Yes. And when you are thinking about market, especially like very competitive market with startups and this kind of environments, the language you choose sometimes is what is going to tell if you're going to be successful or your competitor is going to be successful before you. So this time to market can be interesting in some places, but also there is this uh, kind of computations that needs to be extremely optimized, and in that case Python definitely is not a good solution, right?
How many
So
slides do you have?
I fixed for 20.
Okay, we're almost done.
Okay, so I think C++ is extended C. Mainly the point of the language is to include object-oriented programming. Python can also do this, but it's not required in Python. But in C++, it's the focus of the language. So if you're choosing it, you probably are doing object-oriented programming. And as a comparison with C, I would say that object-oriented architecture would make it easier to work in a project as a team compared to working alone. And it's also very useful for programs that get big, very big. So because it forces things to be more structured, like it forces a way of thinking and solving the problem that makes it more uniform. So multiple programmers can work in parallel in a solution. So I would choose C++ over C in cases I need more people working with me simultaneously, let's say. Um, but one point I think I forgot about the C. C language is very simple. You can fit the entire language in your head, but C++ have many extra tools and it makes it difficult to do this. So you need Google sometimes to do searches to remember how to do things, I think, in C++. That might make you choose C over C++ for something small or simple. So I think is an interesting point, but in terms of efficiency and speed, C++ give you more tools, but I think it's still very close to the C speed. And I think Java programming language, especially like nowadays, I think is not as trendy as before, but still very strong in the world. Uh, its syntax is very similar to C and C++, but it adds some automatic memory management and garbage collection. This would make it a little bit less buggy, let's say. Um, and the the main point of the Java is that it runs on top of this thing called the Java virtual machine. So you can imagine that there are multiple different computers in the world and they are different architectures and different operating system. But if you implement some kind of virtual machine on top of these very different machines, it makes them uniform. So that's the idea of Java. They implement this Java virtual machine for almost everything that you have available, and then you can run your code in all these different computers unmodified. So
the Java virtual machine is tailored to each computer, and then you don't have to worry about that interface anymore.
yes, so that's the trick of Java. So it gives you a lot of portability. You can run the code. The code is written for the Java virtual machine. So you install a different Java virtual machine for different computers, but the program is exactly the same as after it is compiled. You can run the same compiled code in different machines.
Well, in hindsight, it's an obvious thing, but I guess at one time it was a revolutionary concept.
Yes, and this Java virtual machine is, I think I would choose. I never actually worked with Java, but I would choose it if I would have to work with, let's say, Linux and Windows or and Mac computers and program for all of them and want to run the same program. I think this would be a strength for Java. And but this Java virtual machines, it runs slower, it feels slow, and it starts up very slow. So if you run something in Java, you're gonna feel that it takes some time to start. I think everybody that worked with Java programs know that it feels slow. So you have some good points and bad points about this Java virtual machine. But in the industry is very used, and you can run this on the single board computers also. So if you don't need things to be fast, but the program you're running there must run also in a different computer, maybe it will be interesting. So Bash language, Bash actually, you don't compare them directly with other languages because it's the language of the Linux shell, the command line of Linux. So this is something you learn in parallel with the other languages. It can help you solve problems together with the other languages. And you should think of it as a glue language to group existing programs. So I would write a Bash program in cases I needed just to join existing software to work together as a whole, but I'm not implementing anything new. I just joining existing tools. And uh, I don't think it's very strong when you have to do your own logic or math. But if you have already the program that does the logic or math, and you're just joining different programs, then the Bash language would be good for writing a program. So anyway, it's good to learn because you need to talk to Linux as a human when you are programming for these SPCs. So it's good to know a little bit of Bash so you can do some like more advanced things in Linux. And this new Octave, uh, it's a language, but actually the idea is open MATLAB. So I would use it in a context that I already have code written in MATLAB. And this code doesn't require any complex MATLAB toolbox. It's just simple MATLAB code with matrices and algebra. If you run this code in Octave, likely unmodified, it will run off with little modification. So if you already have a program in MATLAB and needs to run in SBC, I would try to run it in Octave and see. Maybe it's already a solved problem. You don't need to program anymore. You just need to run the code you already have. So I think I added this slide because in the engineering community, it's very common for people to have MATLAB solutions, and maybe this could save you time if you look at Octave. And as last programming language I'm gonna like look for in the context of Linux is Perl. I think this language lost a lot of popularity in the latest years because Python rose and took its market. But I think sometimes it has some tools that can make you go to your solution faster, especially when you are doing similar to Bash, joining existing programs, and when or you have to work with text processing. The text processing tools uh, for Perl are very advanced, and I think if you are working with data like tables or CSV files, and you need to extract this data and process, and you read text and you produce text as output, not math in this case, more like the text part, I would take it over Python. So if finding pattern in text is part of your problem, I would recommend this one. And I actually use this one a lot to do small programs that join outputs of other programs and do some quick text processing. So I recommend taking a look.
Well, Victor, hold on. So
yes.
You just said you often use Perl, right?
Yes.
Well, give a good example of that recently.
Recently, okay. So we have in Kitsune project camera controller board is actually an SBC, right? It's controlling the camera. And to do the communication between the onboard computer and this Raspberry Pi, I'm using a program on the Raspberry Pi side. I'm using a Perl program because OBC sends like some text commands, and it receives that and calls a different program in a different language for taking the photo and processing. But all this text manipulation I did in Perl. So in satellite context, I think many of the problems are involved with sending and receiving information, and sometimes this can be seen as text data, or not. Sometimes it's not very mathematical, but just text processing. You process some text, you get the data, and you partition it into parts and send back to the onboard computer. This kind of problem I like to use Perl to solve.
Okay, well, Vic, that's very interesting, because when you first put up this slide, I thought text processing, well, this doesn't have much to do with satellites, and now you totally upturned that prejudice, right?
Yes. There are many like interfaces that send characters to or from subsystems inside the satellite, and everything is characters, so everything can be seen as text. So sometimes for sending and receiving information, the what Perl gives you as the text processing tools make the solutions very short, like few lines of code, which I think can save you some time. But I would not choose it for anything that grows a lot or to do like mathematical processing. But sometimes I would use it to glue things. So I would use Python or C, let's say, to solve the problem. But to do the interface, I would use Perl, just a small program.
Victor, we have to wrap up. Can you wrap up?
Yes. So, in short, I would consider what you already know in terms of languages to choose a language. And I would consider what your colleagues know. But I would also consider what exists in the internet, libraries, APIs, etc., and what language they recommend to use. I would consider what is being popular in the market at the current time, and I would consider what is running well with the Linux and SBC, what makes sense in that environment, right? And as the last point, I would look at the strengths and weaknesses of the languages I have available and try to come up with which one is the most appropriate. So I think this sums up the strategies.
Okay, can you go back to your first slide?
Yes. You mean this one?
No, the cover page.
Yes.
So normally we would take a lot of questions, but we don't have much time now. So if you have a question for the speaker, please use that email address at the bottom.
Yes, please send email. I would like to give you some tips. And I tried to show you today like the main idea of how to come up with a language for your project. So if you take all these things in consideration, I'm sure you all gonna make a good and informed choice.
All right, Victor, that was very interesting and useful, I would say. So let's see, Azami. There's a quick question from Azami. Can you see it?
Hold on. I'll stop sharing. Okay, now I can read. What is my favorite programming language? It's hard to say. I have many favorites, but the ones I like the most, the program is I have most, let's say, fun programming. In a fun kind of sense would be C, because I can do like very low level stuff and have full control. I like that. I also like a lot this one I spoke the last Perl, simply because it gives me so much freedom to come up with quick solutions that sometimes this is like it solves the problem in 1 or 2 lines. And it's great. And I also like one language I didn't mention, very old, called Lisp. Lisp is, I think it started in the 60s, but the if you learn this language, it makes you good in all other languages. It shows you a lot of deep concepts about programming. So I think these three, I would say, make a very strong, like, if you learn and you know how to do like C, Perl, and Lisp, gives a very good understanding of all the languages. And let's say if you go to learn a new language like Python, or and you want to program in that, it makes it very quickly to you to learn and do other things if you have like 3 different languages covering.
Okay, Ramson, can you make it quick?
Yes. Oh, thank you so much, Victor.
Thank you.
It's just to share my experience in programming. I noticed that I think C, it makes things much more easier, especially to learn other languages. So they somehow term it like the mother language. So if you learn C, it will be very, very easy for you to do C++, because C++ it's now like it's now more object oriented. Then if you learn C++, then it now become more easier to do Java. And Python, it will become like very, very simple to do. So most of the syntaxes, they are borrowed from C language,
Yes.
according to my
Technically,
experience.
it comes from Algo, but it's not used anymore. It started with Algo, and all these languages are like descendants from Algo. So it started with Algo, and then let's say C, and then we have the C++, Java, Python. So this lineage of languages, that means if you learn C, yeah, it gives you a
A
very good
clear
background.
insight, yeah.
Ramson, it would be great to continue this discussion, but Victor and I have to jump to another meeting. So
Okay.
Yeah.
I have to terminate this seminar. Thank you, everyone, for attending. Bye-bye.
Thank you.
Thank you.
Bye-bye.